All right, good morning. Happy Wednesday. This is that day when we feel like we're in class all day long because we go to all of our classes. So first of all, I don't know if you have if you're a senior and you've been getting messages about books. You can't return your book in this class until we're done with the class. So you don't want to return your book. All right. It's kind of crazy to me. You know, it gets worse and worse every year. Pretty soon we're going to be turning our books in January. Doesn't make any sense. School's not over. We're using our books. We need our books. So don't turn in your pre-calculus book. Okay. Also, we're going to be taking an exam next Tuesday, and that we're already in the month of May. So it'd be Tuesday, May 4th at 8 o'clock in the morning. So if you want to write that down, exam 7475 at 8 o'clock on Tuesday morning, May 4th. All right. So the first thing I want to do is I want to take any questions you might have. I know there's some things that are coming up that are due. There's actually 7.5 is due tonight. 7.5, the evens are due on Friday. And so make sure that you are paying attention to deadlines because I'm not accepting late work. So every time an assignment's due, I have about 10 people that have either not put their percentages, I'm not doing any of that. I'm not going to be changing grades. I'm not doing things over and over again. So they're due when they're due. When I record the assignments in my book, they're either there or they're not. So make sure you're paying attention to deadlines and that you're inputting your assignment percentage. Okay, anyone want to ask me or anybody want me to do any problems in 7.4 or 7.5? All right, well, I am dressed like this today because I was invited to the girls' soccer game at Grand Terrace. And so I am going to the girls' soccer game. So I know some of you guys are playing on the guys' soccer team. And so if you're still there at the stadium, make sure you find me and say hello. It'd be awesome to meet you in person. So yeah, so once again, you know, you have to have a special invitation. Nobody can just show up at the soccer game these days. So anyhow, I was invited. I will be at the girls' soccer game today at 5:15. So if any of you guys are on the men's team and you see me, make sure you come and introduce yourself so I can meet you. Okay, any questions about 7.4 or 7.5?
Ms. Birch?
Yeah.
For 7.4, I was just having a little bit of trouble with 21. That was the problem that I was like, I don't know why. It just threw me off.
7.4?
Yeah.
Okay, let me get to it. 7.4.21. Okay, this is on page 850, number 21. Equals -7. And then 3x squared plus y squared is equal to 31. So I've been trying to get you, it just says solve using addition, which is stacking. I've been trying to get you to recognize what you have here. And in this particular problem, you will not be able to recognize. So remember that I said that it's a circle if it looks perfect. Well, first of all, this guy right here, he's not perfect. And so this guy would look like an ellipse. And this guy right here, because he has a minus and he's not perfect, it's not a circle or an ellipse. It's something called a hyperbola. And you do not need to know this to do this problem. They just want to know the solutions. So basically you want to know what are all the different ways that an ellipse can cross with a hyperbola. And you really don't need to know that to do this problem. So they want you to solve it using addition. So here's what you can do. You can either multiply the top one by a -3, so you add to eliminate the x squared, or the negative's already there, by the bottom by 4 to add and eliminate. So you do what you want. I'm gonna multiply the bottom by 4. So make sure you keep your work organized, and they said to solve by addition, so I'm gonna stack it. So multiply by 4, multiply by 4, and multiply by 4 would be 124. So when you add, you lose your y squared. So what happens is 12 plus 1 is 13x squared. And then 124 minus 7 would be, what is that, 117? So now when we divide both sides by 13, you get x squared is equal to what? Now, does 13 go into 117 evenly? I think it goes in 9 times. And so now you can set it equal to 0 and use factoring difference of squares, or it's already set up for square roots. Just take the square root of both sides. Don't forget plus or minus. So x is equal to plus or minus 3. So now what you have to do is you have to find the y that goes with -3, and you have to find the y that goes with x positive 3. And so what you do is you choose one of these and find it. Now, I personally don't like all those negatives. So I'm going to put -3 into this one. So this would be 3 times -3 quantity squared plus y squared equals 31. So make sure you follow the order of operations. This would be 3 times 9 plus y squared equals 31. 27 plus y squared equals 31. Subtract 27 would be a 4. And now I'm using square root method again. Don't forget plus or minus. And so you found 2 solutions. You found -3, -2, and you found -3, positive 2. Okay, now, when you put in a positive 3 into that equation, you notice that that's going to be positive, and you'll see you're going to have the exact same problem. So I'm not going to do any work. It's the same exact problem. And now you found 2 more solutions. So you found +3, -2, and you found +3, +2. So there's 4 solutions to this problem. And so what does that tell you about the graph? It tells you that the hyperbola and the ellipse are crossing at 4 points. And like I said, you don't have to know that to do this particular problem. You should be able to do this problem without knowing that. So a couple key things here. First of all, when you do the addition method, you have to get one of the variables as opposites to solve for the other variable. Don't forget, when you're using square root method, you must put plus or minus, because now if you don't put plus or minus, you're going to end up not finding 2 solutions. So it's very, very important that you put plus or minus. So you're seeing me find what y value goes with -3 and what y values goes with +3, but it just so happens that you have 2 y values. So you have to put this x with the negative, and you have to put that x with the positive. And like I said over here, when you start doing this, you notice it's going to end up being the same exact problem. So don't do it. We already did it. All right, any questions?
Thank you, Ms. Birch.
Yeah. Any questions about this? All right, other questions? All right, any questions about the methods? Solving in 7.4, solving by substitution or solving by addition, also known as elimination, also known as linear combinations. Make sure you show your work. If you do not show your work and you just write down answers, I can't give you credit for the exam. So I just want you to know I am going to be looking at your scratch paper. Because I am aware of the programs out there that you can give them the problem, they'll give you the answer. So that's why you submit your scratch paper. That's why you show your work as justification that you are actually doing it and not using one of those programs that give you the answers. I think I told you this, but it doesn't hurt telling you again. There were 2 students on the last test that I gave zeros to because they did that. So there was no work shown and there were like 20-step problems. That's not going to go over well with me. So I'm just letting you know that if there's work to be shown, you're showing the work to justify that you know what you're doing. So make sure you show the work on your scratch paper. The bottom line is, let's stop playing games. It's the end of the year. Let's just, do what we're supposed to be doing and stop messing around, because those of you who are doing that, you notice you don't have great grades, so it's a good lesson to learn that you want to legitimately do anything in life. There's no easy way. There's no free things. It's all blood, sweat, and tears and working hard. And so you want to legitimately, do what you're supposed to be doing. Whenever you're trying to, get by with things and not doing what you're supposed to do, it usually doesn't turn out well. All right, anybody want me to work another problem? All right, well, in 10.1, I did post the sheet of rules. And I think I mentioned before that I do usually have students in class memorize these. So because we're doing distance learning, you don't have to, but you better have the sheet in front of you. So either, print it out, copy it down, should have this sheet in front of you for all of chapter 10. I also put this in the assignment, but I also put it in the material section in Google Classroom. All right. So in lesson 10.1, if you were absent, we're doing some brand new stuff. You have to watch the YouTube video. If you don't watch the YouTube video, you're going to be totally lost. So I talked about sequences and I'm going to be talking about summation notation. So we talked about finding the first 4 terms of a sequence given a rule called the nth term. In the second objective, I talked about recursion. And with recursion, in the original problem that's given, they have to give you the first term. If they do not give you the first term, you can't do the problem, because recursion depends on the previous term, and the next term depends on the previous term of that one, and the next term depends on the previous term of that one. That is recursion. I also talked about factorial notation, and factorial notation is kind of fun because the factorial is an exclamation point, and whenever you see a number factorial, you're working your way down to 1. So for example, if you have 4 factorial, you're just multiplying down to 1. So this isn't the number 4. It is a 4 with a bunch of numbers inside it. So one of the points I was making is don't ever try to simplify something like that, because that is not a 2 and that is not a 4. There's numbers inside there. Okay, so we did a bunch of problems with factorial, and I ended up on objective 4, and that's where I want to start. It's using summation is what it's called. So this is part 2 of lesson 10.1. So summation notation is this Greek letter. And it has a lower limit. And this letter could be anything. Lots of times you see I or N, it could be J, and it could start at different numbers. So it could start at 5, it could start at 9. You got to pay attention to the lower limit. I'm going to label that in a minute. The upper limit is usually some number, like 20, 30, it could be anything. And so what happens is you have some type of rule, and the rule represents a sum. And you'll see what I'm talking about when I do some examples. So for now, you're going to write, this is the lower limit. This is the upper limit. And this I is called an index. So let me show you, that's the definition, but let me show you, it'll be easier to see a problem than the definition. So in a problem, they're going to say expand the sum. So look at what this says. It says expand, which means make bigger, and evaluate means find a number. So here's the problem. The index is I, and they're saying the lower limit is 1 up to 6. And they're giving this thing. All right, that thing is called the rule. So here's what this is saying to do. It's saying to do a loop. So it's saying put a 1 in and then put a plus sign, put a 2 in and put a plus sign, put a 3 in and a plus sign, 4 in a plus sign, 5 in a plus sign, and 6. So they want you to use this rule from 1 to 6. So watch what you're going to do. You're going to take that and put a 1 in, plus. Then you're going to put a 2 in. So then you're going to put a 3 in. Then you're going to put a 4 in. Then you're going to put a 5 in. And then you're going to put a 6 in. And so basically what this is, it's a shortcut for writing that big old long expansion. So I'll say it again. This is a shortcut for writing this from 1 to 6. And so notice what this says. It says expand, which we did. And now it says evaluate, which means find a number. So we have to multiply these things out and we have to add. All right, so here we go. So 1 squared plus 1 is 2. 2 squared is 4 plus 1 is 5. 3 squared is 9 plus 1 is 10. 4 squared is 16 plus 1 is 17. That's 25 plus 1 is 26. And 36 plus 1 is 37. Now, I would not put it in the calculator. The more you have to put in a calculator, the more chance you have of making a mistake. So what I would do is add these up and then put them in the calculator. So I would probably say, okay, well, I have 2 and 5 is 7 plus 10 is 17. And then 17 and 26 is what? 43 plus 37. And now I would put it in the calculator. So 17 plus 13, 43 plus 37, what do you get?
97.
97, and that's your answer for evaluate. So pretty easy. If you see what's going on, you all should be able to do this.
So Ms. Birch, so for expand and evaluate the sum, so basically you're just gonna be like multiplying and adding
Yeah.
for that step? Okay.
Well, this rule can change.
Oh, rule, yeah.
It could be anything. It could be 3x plus 1. You know, it could be I squared plus I plus 7. It could be a fraction. So this rule could be anything.
Okay.
So what you have to do is make sure you look at the lower limit. And if it starts at 5, you're going to put a 5 in. So you have to pay attention to the lower limit, and you have to pay attention to the upper limit to know when to stop. So the lower limit tells you where to start. The upper limit tells you when to stop. Let's try another one, okay? So the way you read it is you say the sum from k equals 4 to 7. So it's the sum from k equals 4 to 7. Here's the rule. And notice that the letter on the bottom, the index, always matches the rule. So you're never going to see like a K and an I. You're always going to see the I match the I and the K match the K. Otherwise, you can't substitute into the rule. So remember, you want to substitute into the rule, you have to substitute into the proper variable. So this is what this looks like. And so I'm going to make a note that the index can be any letter. That guy. And in this case, we're going to start at 4. Okay, so here we go. So we're just going to write this down. -2 to the 4th minus 5 plus, because it's a sum, -2 to the 5th minus 5 plus -2 to the 6th minus 5 plus -2 to the 7th. Is that the last one? I'll write it over here. Plus -2 to the 7th minus 5. All right. So basically, we did a loop, and we started at 4, and then we went to 5, then we went to 6, then we went to 7, and these are all added. So watch your, do not show it as multiplying. It's all a sum. It's all added. Okay, did you guys get that? Can you guys unmute yourself and tell me? Aurelia, Alex, Brandon, Georgina, Jessica, all you guys? Okay. I didn't hear any of the girls.
Yeah, we got it.
Jessica, are you there? Cecilia, Aurelia? All right. Now we might have to show some work on this. It may not be something we can do in our head like we did on the other problem. So here we go. What's a negative raised to an even power? Come on, guys. What's a negative raised to an even power?
A positive.
Right. So 2 to the 4th would be 16 minus 5, and I'm not going to do too much in one step. What's a negative raised to an odd power?
A negative.
Right. So I'm going to put a minus, and what's 2 to the 5th? 2 to the 5th?
$32.
What's a negative raised to an even power? positive. What's 2 to the 6th?
64.
And finally, what's a negative raised to an odd power? Negative. What's 2 to the 7th?
128.
Okay, is it 128? Okay, so now we just do what's inside. So 16 minus 5 would be 11. 32 minus 5, what is that, 27? 64 minus 5 would be what, 59? And what's 128 minus 5? 123? Is that right?
Yeah.
So now I'm going to put the positives together. So 11 and 59 would be 70. And a negative is a negative, and you add, that would be what, negative 150? Or is that 170?
It's 80.
It's what? Hold on a minute. I think I messed this up. Okay, you see how I brought this negative out and I wasn't being careful? I actually did not follow the order of operations properly by bringing that negative out. So let me do it again and be more careful. Because I can tell this is the order of operations isn't right. Sorry about that. Let me try this again. All right. All right, so I'm just gonna put the plus sign. Okay, that is what? Negative 35 minus 5. And that would be a positive, what'd you guys say that was? 2 to the 6?
64.
And then a negative would be, a negative to an odd power would be negative, what's 2 to the 7th?
128.
Okay, so I'm gonna do this right this time.
Ms.
So this would
Bird,
be 6, yeah,
that negative 35 is actually negative 32.
negative 32?
Yeah.
Thanks. Okay, does that look better? So this would be 11. A negative and a negative is a negative, and you add. 64 minus 5 would be what, 59? And a negative is a negative, and you add would be 133. So now, like I said, put the positives together. So that would be 70. And a negative is a negative, and you add would be, I think it's 170. So now it depends on the sign of the bigger numbers. So it's negative. When you subtract, you get negative 100. So that is the correct answer. So you want to be really careful and don't do what I do with the order of operations. You want to make sure that you work. Please excuse my dear Aunt Sally. Make sure you follow the order of operations. I got careless and put a negative, which affected the whole thing. This is a negative 32 minus 5. That's a positive 64 minus 5 and a negative 128. So a negative and a negative is a negative and you add. Negative and negative is a negative and you add. Then you put the positives together, then you put the negatives together, and that is the correct answer. So you see what I'm saying about the rule? This rule is more complicated than that one because the index was a power. Now I want to show you a special case. And this is actually on the sheet that I provided for you. So this is one of the special cases. It goes from 1 to 3, but look at this. It's a constant. Sorry, 1 to 5. So it's like, hold on, Miss Birch. How do we substitute a 1 in? There is no variable. And you're right. This is a special case. And what we're going to do is just circle, or actually, we're just going to multiply the upper limit times 3. See, I can write this so you can remember. Multiply 5 times 3. So basically, let me just show you what it means. It means to add 3 5 times. So it'd be 3 plus 3 plus 3 plus 3 plus 3, which is 15. But what's easier than doing that is just to multiply those two. But that's what it means. It means add 3 5 times. Okay, would you like me to do any more of these, or do you guys understand what's going on with this? So this is summation notation, and this is a short way of writing a sum addition. And what we do is we evaluate it by expanding it out and evaluating. Okay, last call. Do you want me to work another one of these problems, or are you guys okay? All right, now we're going to go backwards. And what they're going to say is they're going to say express each sum using summation notation. So we're going backwards. So for example, they're going to give you a sum like 1 cubed, 2 cubed, 3 cubed, and then they're going to put plus. That means there's numbers in between. And then it's going to end at 7 cubed. And what you have to do is you have to come up with summation notation and a rule. So you have to come up with the lower limit, the upper limit, and the rule. I don't know why I can't draw this today. So we'll start with K. So what do you guys think the rule is? It's something being cubed, right? So what number do you want to start with? What number do you want to end with? And what should our rule be? Go ahead, I'm listening. Go ahead, I'm listening. Do you want to put a K plus 1? Do you want to put just K? Do you want to put K over 2? Like, what do you want your rule to be? Isn't it just K cubed? If you put a 1 in, it's 1 cubed. Put a 2 in, 2 cubed. Put a 3 in, 3 cubed. Put a 4 in, 4 cubed. All the way up to 7 cubed. Isn't that it?
Oh, yeah, yeah.
And shouldn't we go up to 7? Yes, no? All
Yeah.
right, let's try another one. Okay, this means there's numbers missing. And at the end, they have 3 to the n minus 1. So if they want us to write a sum, you can use I. The rule has a 1 on the top, doesn't it? And what's happening with the I on the bottom? What's it doing? Well, check this out. If we start at 0, this kind of gives us the rule at the end. So if we put 3 to the I minus 1, so n minus 1's up there, but if we put I minus 1, maybe we do start at 1, sorry. If we put a 1 in, wouldn't that be 3 to the 0? So wouldn't that be 1 over 1? If we put a 2 in, wouldn't that be 1 over 3 to the 1? If we put a 3 in, wouldn't it be 1 over 3 squared, which is 9? And to get the rule, or get the end, we would go up to n. Because the very last term would be 3 to the n minus 1, which gives you the last term. So basically what you're trying to do is you're trying to write a rule that is equivalent to the sum. You're trying to trying to write something in summation notation that's equivalent to that expansion. Questions? It's like a puzzle. You're trying to figure out what the rule is that represents this. And you know that you're correct. If you expand it out and you get that, then it means that's correct. But let's look at some special formulas that I put on that sheet. We already looked at one that I gave you just a minute ago. Now, these special formulas are used just to help you out. So the first one is k equals 1 to n of a constant. That's the one that I showed you. You just multiply the top. The second one looks like this. It's k equals 1 to n of just a variable k. So that's linear. And the third one is the sum of k equals 1 to n of k, the quadratic. And there's others. Let me find them for you. Thought there was others on another page, maybe not. Don't worry about it. So I want to show you how these work. See, these are special cases. And basically, these special cases are to help you so you don't have to do a lot of work. I actually forgot to write out the rules. So this one is equal to, just like I told you, multiplying those, that's equal to n times c. This one is equal to n times n plus 1 divided by 2. And this one is equal to n times n plus 1 times n plus 2 divided by 6. And I'll show you how these work. So for example, if you have k equals 1, 5, up to 10 of 8. Now, you cannot multiply the 10 times 8 on this one because it doesn't start at 1. Let's do it. If it started at 1, you would just multiply 10 times 8 or 80. But because it doesn't start at 1, it starts at 5, you would have to figure out how many terms you have. So you would have 5, 6, 7, 8, 9, 10. You have 6 terms, right? 5, 6, 7, 8, 9, 10. So the answer would be 6 times 8 or 48. So this one's tricky. So you can use the rule, but you have to be careful. This is 6 terms. The index starts at 5. So just to reiterate, if you have a special case and it starts at 1, you could just multiply the upper limit times the constant. If it starts at some other number other than 1, you're going to have to find out how many terms, and you're multiplying the number of terms times 8. Let's do another problem that's a special case. So you know what I'm talking about here? Let's say you have k equals 1 to 5 of k. Okay, you should recognize that it's this one right here. So when you recognize it's that, you don't have to write out the sum, which you could if you wanted to, because this is an easy problem. But what if this wasn't a 5? What if this was 25? I don't want to write all that out. I don't want to put 1 plus 2 plus 3 plus 4 plus 5 plus all the way to 25. I don't want to do that. So I'm going to use this rule. And this rule says to take n, which is the upper index, and you're going to multiply 25 plus 1 over 2. So that's the beauty of this rule, is if it was a simple problem, just do the sum. But I don't want to add all the way up to 25. So I'm going to use this rule. So these are the rules. So let's do the problem. So this would be 25 times 26 divided by 2. And you can cancel parts of a product, right? So I'm going to cancel the 2 and the 26 and make that 13. Now I'm going to use a calculator. What's 25 times 13? I don't know. So what's 25 times 13?
325?
325?
Yeah.
All right. And finally, let's look at the last rule. Now, these are special cases. So check this out. What if you saw this? you're going to notice right away that it's a special case. And instead of adding one or doing the 1 squared, 2 squared, 3, all the way up to 7, especially if this was a bad problem, let's say it wasn't 7. Let's say that it was 14. We don't want to do all that work. So we're going to use this rule that says you're going to take the upper limit times n plus 1 times 14 plus 2, all divided by 6. Now, some people ask me, Miss Birch, is this always a 6? Yes, it's a rule. Is this always a 2? Yes. And the n is always the upper limit. So what I'm going to do is I'm going to take 14 times 15 times 16 and watch this. I can divide the top and bottom by 3. I can divide the top and bottom by 2. And now all I have to put in the calculator is 4 times 40. Right? 5 times 8. So what's 14 times 40?
560.
Okay. Okay, and that is the lesson. I am done. Okay, have I run past time already, you guys? You guys are so patient. Okay, we're past the time. Why you guys don't tell me that? Okay, I did finish the lesson though. All right, so thank you for your patience. Thanks, guys. Have a good day, okay?
Thank you,
I
Ms.
did
Birch.
finish
I
the
appreciate
lesson. All right, you guys. All right, thank you so much. Thanks for being patient.
Bye,
Bye,
Ms. Birch.
guys.
Have a great day.
Thank you. You guys have a good day too. Bye. Bye, guys.